So from your study material, you will get everything there. So introduction part, matrices. So matrices is nothing but it is the arrangement of some symbols or some letters or some numbers in a particular row and column, and it is being embraced with or it is enclosed with some bracket, and that bracket can be parenthesis or common bracket or curly bracket or square bracket, any bracket. So arrangement of matrix, when they are arranged, there is no particular limit of orders. There can be any number of rows and any number of columns. So they are being denoted by, if suppose matrix is given, so how many number of rows and how many number of columns are given in this way, 3 by 4, or you can call it as 3 into 4. Okay, so 3 by 4 means 3 rows and 4 columns. So above example, if you will see there, 3 rows are given, that is in row wise 11, 42, 22, 84, and second row 10, 15, 60, 25, and third row 41, 28, 45, 51. In this way it is arranged. And similarly 3 by 4 it is given, so 4 denotes the column. So in column wise, if I read out the elements, so first column 11, 10, 41, then second column 42, 50, 28, then third column 22, 60, 45, and fourth column 84, 25, 51. So this is the arrangement of some elements. Element, as I told you earlier, it can be any symbols or any alphabet, or usually it is number. Okay, so each and every element, they have a particular positioning and they have a particular name. Here you can see the one which I have zoomed. You can see there every element has its name. Then you can see here first A11, that means A11 represent element of first row, first column. It is also denoted as Aij also. Okay, many books you can see there Aij is represented. So I is row and J is column. So similarly a number it is given. So first digit represent row and second digit represents column. Okay, so if I'll say that here, if suppose A21, A21 means second row, first column. Similarly, if A32 I'll say, A32 I'll say, then A32 means third row, second column. In this way, it is being named or positioned. Okay, and it goes on. It is unlimited. Okay, so there is no necessary that number of columns and number of rows should be equal. Here, unequal number of rows and unequal number of columns can be there. Then come to types of matrices. So every matrix is categorized according to their elements and their arrangements. Okay, how many number of elements will be there, and as per their arrangement it is being categorized. So if suppose see first one, row matrix is given. So here you will see only one row will be there. In one row only, any number of columns can be there, but one row will be only there. So example, you can see only in one row elements, three elements are arranged in a column, but one row is given. Okay. Similarly, column matrix, only one column will be there, but number of rows can be there. Then come to rectangular matrix. Three columns are there. Okay, and it is shaped as rectangular. You can see there. Then come to square matrix. So square matrix is the equal number of rows and equal number of columns. Number of rows and number of columns should be equal. Rows n represents columns. Then come to diagonal matrix. So diagonal matrix, you can see here the arrangement, how it is arranged. You can see all the non-zeros are arranged diagonally. Okay, one corner to another corner. That is diagonally, it is arranged only with numerical other than 0. But apart from the diagonals, you can see there all elements are zeros. Only the diagonal elements are non-zeros and other elements are zeros. So such type of matrix is known as diagonal matrix. Now from here, further categories are being there. From here, if you will not understand, further you will not understand. So diagonal matrix, from diagonal matrix, next is scalar matrix. Okay, to satisfy the condition of scalar matrix, first it should be a diagonal matrix. That means diagonal matrix, non-zeros in the diagonal part. Okay, that means principal diagonal. Principal diagonal here is the leading element at the top of the corner. Okay, so scalar matrix means it should be a diagonal matrix, but all the elements in the diagonal should be non-zero and same. Okay, and same, identical. Here you can see if -3 is there, so all the diagonal elements should be -3. If suppose -3 is not there, other elements, suppose 4, 4 it is given, so all the diagonal elements should be 4. Okay, then come to identity matrix. Again, then identity matrix, identity means unity, that means 1. So all the diagonal elements should be 1. Okay, so here it is related one, diagonal, then scalar, then identity. Then come to triangular matrix. So triangular matrix, here you can see that one part of the diagonal is non-zero and other part of the diagonal above the diagonal are zeros. So in this case, two types of triangle matrix are there, lower triangular matrix and upper triangular matrix. So in case of lower triangular matrix, you can see that lower part of the diagonals are non-zero and upper part of the diagonals are zeros. So this is the condition of lower triangular matrix. Then upper triangular matrix.
मैम म्यूट है।
Ma'am, you are not audible.
Sorry, it was mute. Sorry. Now it's audible.
Yeah, ma'am.
So here, if suppose two metrics are given and if we have to add or subtract of two metrics, then their number of rows and number of columns should be equal. And elements in whichever place they are placed, they will be simplified in that particular position. Suppose A has element of 0. So in B, in the same place, whichever element is placed, with that only it will be simplified. If suppose A plus B is given, if you have to add the elements of A and B, A plus B if it is given, so 0 will be added to 7. Similarly, 2 will be added to 5 and 2 will be added to 3 and 1 will be added to minus 1 and 3 will be added to 5 and 4 will be added to minus 3. And whatever simplification is necessary, all you have to do, you can simplify there. Okay. Similarly, same condition is applied for subtraction. Same condition is applied for subtraction. But here you can see the difference is that A plus B can be equal to B plus A. But A minus B is not equals to B minus C. One condition is there. Okay. In properties, you will see there properties of addition and properties of subtraction. So same necessary conditions is applied for subtraction also. And next is multiplication. Okay. So multiplication, there are two types of multiplication. Only one is given, I think. So multiplication matrix, multiplication of matrix by scalar quantity. Okay. So according to that, any constant number is multiplied with the elements of a particular matrix. Here you can see if A is a matrix. So if 3 is multiplied with A, so 3 will be multiplied with all the elements of A. That is the scalar matrix, scalar multiplication as for that one. So some of the properties are given of addition and addition subtraction. So properties of addition of matrix, this is given as per the equation. You can see, as I was telling you, A plus B can be equal to B plus A. Then addition of matrices is associative. How it is associative? You can see there A plus B, if it is in bracket and if it is added with C, it can be associative with the following equation, that is A plus B with bracketed B plus C. Then existence of additive identity. If suppose A plus null matrix, O represents null matrix, is equals to null matrix plus A, that is equals to A. Okay. Then existence of additive inverse. Inverse means minus you can say, or the reverse you can say. A plus minus A, that is inverse of A, is equals to inverse of A plus A equals to null matrix. That is the properties. As per the properties, some questions are being solved. Okay. Some examples are given here. Then multiplication of two matrix other than the scalar. This is multiplication proper. Okay. So how it is multiplied? Directly come to example. Okay. So here you can see the condition first should be fulfilled that number of columns. Okay, number of columns and number of rows of another matrix should be equal. How it is multiplied, you can see here. Here you see, I don't have whiteboard, so I can't explain. So just go through these examples only. So if suppose first column we will take, first column of the first matrix. Okay, first column of the first matrix and first row of the second matrix. How it is multiplied, you see. So if suppose 1 into 0, 1 into 0 means 1 is the element of A and 0 is the element of B, which is placed in first column, first column and first row only. Okay, 1 into 0 plus 3 into 5. First row you see, in first row, second column, 3 is there. So 3 into 5. So 5 is placed in B of the second row, first column. Okay, that means how you will multiply? First row, first column, first row, second column, first row, third column. In that way you will multiply. Okay, with the plus sign. So suppose 1 into 0 plus 3 into 5 plus 5 into minus 1. Okay, this is one part. Now second part, 1 into 1 plus 3 into 2. This is C12 is representing first row, second column. Okay, so 1 into 1 plus 3 into 2, then plus 5 into 2 and simplification. Then first row, third column. First row of A and third column of B. So 1 into 2 plus 3 into 1, then plus 5 into 1. You will get this answer or result. Then come to second row, first column. Then it will go to second row, second column, then second row, third column. Okay. Now, if you will arrange it, it will be arranged in this way. That means A into B after getting the result, and the elements are arranged in this way. That is, first result you have got 10, then 17, then 10. That is in first row. Okay, first row. And second row you will see that minus 4, 1, 8. Okay, it is arranged in that. So you will see that after simplification or after multiplication, you will see that the data is arranged or the elements are arranged as per the first matrix. Okay. So in this way it will be multiplied, and some of the examples are given. Then properties you see, associativity. It is associativity as per the equation you see, A into B in bracket into C. That is equals to A into B into C. Distributive over addition, that is A into B plus C. If it is given, it can be distributed in this way, that is A into B plus A into C. Then identity matrix, as per the identity, A is equals to A into identity matrix. Okay. Some examples are there from your study material. Go through it. Then come to transpose. Okay. So before here you see in your study material transpose is given, but before transpose is that the changing of rows into column or columns into rows. Simply that one and nothing else. Okay. And symbol can be A to the power T or A complement, you can denote it, A transpose. So A transpose of a matrix A is nothing but it is the changing of rows into columns or columns into rows. Okay. Nothing. No simplification is required here. Then some other matrix are there. That is symmetric matrix. Examples are given here. You can see that. Skew matrix. Only examples you can see and you can understand. Then next is determinants. Determinants is similar to matrix, but it is different in one case. That is, in determinant, it should be a square matrix. Okay, square matrix means number of rows and number of columns should be equal. Here also some algebraic operations can be done. So matrix is also same thing. That is, determinant is also the same thing, but here the difference is that number of columns and number of rows are same. And same here, same arrangements are there. It is enclosed by some brackets. Okay. So determinant here you see, if this example you see, it is arranged in this way. So here, how you have to obtain the value of determinant. So every element here, every element have their position name, but here one thing is there, every element has its sign, okay, plus minus sign. So if it is simplified, you have to take into consideration of plus and minus signs, okay. So first element, if suppose I'll tell you 2, starting with 2. So 2 has sign of plus, okay. Then next element will sign of minus, that the next element will be has the sign of minus, okay. So plus. So plus minus plus, just the alternative, just the opposite sign below the element, minus, then plus, then minus, then again plus minus plus, okay. It is arranged in that way. So if you have to simplify, if I will take the first element 2, 2 has the sign of plus, okay. 2 has the sign of plus, so plus 2. And its minor element, that means how it is taken, leaving the first row and leaving the first column wherever that particular 2 element is given, okay. Leaving that row, leaving that column, whatever element is left, that are the minor elements of 2, okay. It is arranged like that. Then next is minus 1. Why minus 1? Because next element has sign of minus, okay. So its minor elements are leaving that row, leaving that column, 1, 1, 1 minus 3, okay. Then next is minus 1 is given, but already it has a sign of plus, and that's why plus with minus 1. Afterwards, after opening the bracket, it can be converted into minus, but before that you have to show that what symbol or what sign it has. So it will be plus. So plus in bracket minus 1 and its minor elements 1, 1, 1 minus 2. Then after that, minor elements are diagonally multiplied. So here if you will see plus 2 and its minor elements, if they are given 1, 1, minus 2, minus 3. So diagonally you will multiply, that means 2 already it is there. So 1 into minus 3, then minus 2 into 1, that will be plus 2, okay. Same you will multiply in the other parts also. And don't forget the symbols, because if the signs will change, answer will also change. So after multiplying and simplifying, you will get the result of 5, okay. Then come to properties. So first property says that if all rows and columns of determinants are interchanged, okay, of rows and columns, if they are interchanged, then the value of determinant does not change. Even if you will change the rows and columns of a particular determinant, the value will not change. Then second property says that if any 2 rows or columns of a determinant are interchanged in a particular determinant, if any 2 rows, okay, any 2, in first property all the rows and columns it is said, but in second property any 2 rows it is said, okay. So if any 2 rows or columns of a determinant are interchanged, the value of determinant remains the same, but sign is reversed, okay. If suppose answer comes minus, if you will change the 2 rows and 2 columns, interchange the 2 rows and columns, so it will change into plus. If it is plus, then it will be minus. That is the difference. Then third property says if any 2 rows or columns of a determinant are identical, the value of determinant is 0. Okay, this is the another property, that if 2 rows or 2 columns are identical, here you can see second row and third row, they have same element. Okay, so same element means it will become 0. Even if you can prove that by simplifying the above by minor method. Then if all the elements of a row or column of a determinant are multiplied by some number, some number, say k, any constant number, if it is multiplied, then the value of determinant is multiplied by that number. Okay, so if suppose one is, that is 2 is one case. Okay, 2 is a constant which is multiplied with the number elements of first row. Okay, then you will get the answer in that particular time. Suppose here it is one determinant, and after simplification answer is 56. Okay, so if suppose that same determinant is multiplied by 2 of the first row, so in that case, whatever the answer was there, it will of the same time. That means 2 was multiplied, so answer will be 56 into 2 if you will multiply it with one constant. Okay. Then if all the elements of row or column of a determinant are added or subtracted k times, any particular number times, the corresponding elements of another row or column, the value of determinant remains unchanged. Okay, a particular number, if it is added or multiplied or subtracted, the answer will come same. This example you can see. Okay, then next property is, if all the elements of row and column of determinant are some difference or two or more elements, then determinant can be expressed as the sum or difference of two or more determinants. Okay, so here you can see that how it is being separated in the third column. How, suppose if you see 5, third column you will see third is separated 2 plus 3. So if suppose it is separated in this way, it can be formed two determinants with the particular sign, plus or minus sign. If you can see third column 5, 1 minus 3 if it is given. So if suppose it is separated into a particular number with plus. Okay, so 2 plus 3 that will be 5, 0 plus 1 that will be 1, then 2 plus minus 5. Okay, that will be minus 3. So 2 plus 0 plus 2 plus if it is given, it will be separated with plus. Okay, with the third column, two different columns will be there with different elements. It can be separated simply. Okay, then minor and cofactors. So minor and cofactors, already when simplification I have told, in that I have explained. So minor cofactor, here formula is important. Formula you will see, cofactor. The formula for cofactor is minus 1 to the power I plus j. I represent particular row and j represent particular column. Okay. So in second order matrix, second order determinant, minus can be easily identified, because if suppose here second order is not given, only third order is given. So third order, you can see here how cofactors are being found out and how minors are being found out. Okay, so here you will see that cofactor, simply the formula is minus 1 to the power I plus j, and minor is equals to, that is my cofactor into minor of particular element. Okay, so here for example 165,321 minus 2 0 minus 3 is given. If suppose you have to find out the minors, suppose one example you see, minor of 1 1. A11 means minor of the elements of first row, first column. Okay, the same I, that is ij, the same digit will be taken as I plus j. Okay, whichever position of element you are finding out, that you will be taking as I and j. So minor of 1 1, that is minus 1 to the power I plus j. Here I is 1, j is 1, and they are minor elements. That means if you are taking first element of first row, first column, leave that row, leave that column. Whatever elements are left, that you will take it as minor elements. That is here you can see 2 1 0 minus 3. Okay, so by simplification, minus 1 to the power 1 plus 1, minus 1 to, that is 2 into minus 3 diagonally multiplied, minus 0 into 1. Okay, so here after simplification it will come minus 6. In that way every element will be found out. Okay, so this is the, then come to Cramer's rule. Cramer's rule is applied in linear equations. How to solve it? Okay. So how elements are taken? Only third order it is explained here. So if suppose linear equation is given, it is solved by Cramer's rule to find out the value. Okay. Suppose linear equation of 3 variables are given. Okay. Third order means there should be 3 variables. So if suppose this linear equation is given, x minus 4y minus z equals to 11. 2x minus 5y plus 2z equals to 39. Minus 3x plus 2y plus z equals to 1. If it is given like that, how you will take the elements? So all the coefficient of the variables. Coefficient means the multiple of the variables, that is x, y, z. You will arrange it into rows and column. All the variables, all the coefficient of x will be first column. All the coefficient of y will be second column, and all the coefficient of z will be third column. You can see here only x means 1, 2x means 2, minus 3x means minus 3. Similarly, if coefficient of y, that is minus 4y means minus 4, then minus 5y means minus 5, then plus 2, only 2, then minus z, that is minus 1, then 2, then 1. Okay. First you will simplify simple determinant, you will solve it, the value of simple determinant. Then for D1, what you will do, after equal to whatever digit, okay, that is 11, 39, 1. That are the elements to be replaced in first column. To finding out the value of D1, first column should be replaced by the value of 11, 39, 1 of the linear equation. Okay, the product of linear equation. Then all other elements will be same and same, simplified. Then for D2, second column will be replaced. Then for D3, third column will be replaced. And by the given formula, the value of x is equals to D1 by D, and the value of y is D2 by D, and the value of z is D3 by D. Okay. Some other examples are also given. Then come to fourth one. So how it is applied? Okay. So in many cases, metrics are applied for calculating the minimum cost per unit. Okay. So minimum cost per unit, how they are calculated, it is used there. Some examples are given. So how it is arranged and how they are calculated. And here some examples are given. You can see there. So suppose, second example, let us take an example, how matrix is used in that particular example. So in an elocution contest, a participant can speak either of the 5 languages. Okay, 5 languages are there. So participants are there, so they can speak in the speak those languages. Okay, so these are the language. So here you can see college A. Okay, so if suppose number 1, first college sent 30 students, out of which 10 offered to speak Hindi, 9 English, 6 Punjabi, 3 in Gujarati, rest in Tamil. Okay, out of 30 students. So you can see here in arrangement, simultaneously see the arrangement. In college 1, how many number of students they speak Hindi? English 9, Punjabi 6, and Gujarati 3, and rest of the 30, that is Tamil. In this way it is arranged, and after arrangement, okay, after arrangement it is clarified that how many students they have spoken in a particular language. It is just an arrangement. Okay. Then many other examples are also there. Then market demand and supply equilibrium, how it is found out. Okay. So there is a particular equation. You can see here, if demand and supply curves for car are in this way, suppose example is given. So D equals to 100 minus 6P, S equals to 28 plus 3P, where P is the price of car, what is the quantity of car bought and sold at equilibrium. Okay, so it can be found out in the following way, that is equilibrium quantity will be where supply equals demand. That means supply is equal to demand. So first we will set supply equal to demand. That means whatever the demand is there, supply will be equal. In this way, equation is being arranged, and after rearranging, we will get that 72 equals to 90 and P is equals to 8. Okay. See, after simplification, you will get. And since we have worked out the equilibrium price, we can solve for the equilibrium quantity by simply substituting P equals to 8. Okay, into the supply or the demand equation. That is, if P is substituted into the supply equation to get, if suppose supply is equals to 28 plus 3P is if it is given, so 3 into 8 and 28 plus 24, that will be 52. Okay, so equilibrium price will be 8 and quantity will be 52. Some other examples are also given. Okay, you can see there. The national income model, here some other equation is also given. So if suppose national income is equals to consumption plus investment, autonomous investment, first equation, as per this equation, and second equation if it is there, that is consumption equals to A and B are constant, so A plus B into national income, that is Y, and then another equation, that is third equation, national income minus consumption, that is equals to autonomous investment. Okay, whatever income you will get, out of that if you will deduct the consumption, you will get the investment. Okay, and fourth equation, if suppose constant B minus national income plus consumption, that is equals to A. A are the constants. Okay, as per the given equation, it is solved in this way. And this is the example of inverse matrix. Okay, this is the example of inverse matrix, which is I think solved in next chapter. Here it is given like that, but this is the example of inverse matrix. Okay, so inverse matrix is given, the same example. Their input output table is given. Just go through it. Then technological coefficient matrix are given. Then Hawkins-Simon conditions are given, just the theoretical part, just go through it, you will understand. Then closed and open input-output model, same here also. Then come to, I think third part, inverse matrix. Inverse matrix here you see, I've skipped that part. So here, inverse matrix, the formula for inverse matrix is there. How to calculate? I will tell you only that one. So inverse matrix is denoted with a to the power minus 1. Okay. A to the power minus 1. Here formula is not mentioned. So I will tell you that is inverse of matrix is equals to 1 by determinant of A into adjoint of A. Okay. Or simply adjoint of A divided by determinant of A. First what you will do to find out the inverse, first you will find out the determinant, the value of determinant. Okay. Then what you will do, if suppose the value of determinant is non-zero, if the value of determinant is non-zero, then you will continue to find out the adjoint of A, of the matrix A. Okay. So adjoint of matrix is nothing but it is the transpose. First transpose means changing rows into columns or columns into rows. First you will find out the cofactor, then transpose that cofactor. Then you will get adjoint of A. And it is symbolized as ADJ, that is adjoint of A. It is given at the last part of this chapter. You can see first, I think from in this chapter, first adjoint should be given, then inverse should be given. Because after finding out the adjoint, then only you can find out the inverse. Okay. So inverse is nothing, adjoint of matrix is nothing but it is the transpose of cofactors of the elements. So here first you will find out the cofactor, then you will transpose. Okay, here some properties are given. Properties, you will go through it. So here first cofactors are given and then it is transposed and you will get the adjoint of A. So finally, here you can see the formula is given, adjoint of A. Okay, so here just ignore that A. Here if you will see that inverse of A, that is denoted with A to the power minus 1. Adjoint of A divided by determinant of A. And again, once again I will repeat, if suppose determinant of A is 0, so further calculation is not possible. Okay. Some equations are given. You can just go through it. So coming to the last part. So mathematical functions. Okay. Functions are nothing but it is the value to be substituted in a particular function. Okay. If suppose f of x is given, f denotes with function, that is small f. F of x, if suppose it is given f of x equals to x square. So here, if suppose you will substitute the value of x with 3. So if suppose in that particular equation, if 3 is replaced in x, so x square will be 9. That means 3 square, that is 9. So that means you are replacing the value of x. So some types of functions are there. So relation between x and y, how it is related you see. So if two groups are given, x and y, so they are related with each other in this form, in a diagrammatic form it is given. Okay, that means each element of x is related to y. Okay, if suppose any one of the elements, if they are left, that means there is no relationship between x and y. Okay, so then domain and codomain and range. So here particular equations are solved to find out the domain, codomain and range. So here you can see examples are given. Examples. So domain, codomain, usually they are found out while drawing the graphs. Okay. So some of the functions are, some types of functions are given here. You can see, you can go through it. Functions, types of functions are given. I will directly come to the graphs. Okay. So some examples are given with the diagrammatic form. Go through that. So I was talking about the domain and codomain. Okay. Or domain here means the value of x, and codomain or range is found out after the value of x is substituted in that particular equation. So while drawing the graph, you need to find out the coordinates. Coordinates means the value of x and y. Okay. So in the following equation, if suppose y equals to 2x plus 3 is given. So here if suppose you will substitute the value of x, when you will substitute the value of x, it will be called as domain. And when you will get the result after simplifying this 2x plus 3, then it will be range, or codomain also it is said. Okay. And after finding out the value of x and y, the graphs are being drawn. Okay. So some examples of graphs are given here, you see, by solving the linear functions. So if suppose first table you see how you will find out the domain and codomain. Usually domain you will substitute by yourself, and according to that domain you will find out the range. Okay. So here you see, if suppose y is equals to 7 minus 5x is given. So if suppose x, the value of, in first case, if the value of x is substituted with minus 1. So after simplifying 7 minus 5x, it will be 12. Okay. So the value of x is y minus 1 and the value of y is 12. So in the particular graph, first coordinates are 1, 12. That means in x-axis -1 you will point, and in y-axis 12 you will point. First you will point out that one. Similarly, placing 0 in x and finding out the value of y, and similarly minus values over, then plus values you can substitute, and after substitution of x you will get the value of y. Okay, so in the graph -1, 12 that you will point out, then 0, 7, then 1, 2, 2, -3, then 3, -8. After pointing out, draw the line by joining all the points. What you will get, you will see afterwards. Okay. Then some of the graphs are given in this way. That means absolute value function. If you will draw in a graph, it will show you in this way. Okay. Then step function. If step function, if it is drawn in the graph, it will be shown in this way. Okay. So some of the graphs, they are shown in this way. Then curvy types. If suppose you are showing quadratic function, in case of quadratic function, you will see that graphs is in a U shape. Okay. Various other types of graphs are there. You can go through it, how they are being simplified, how domain and range are being found out by solving the equations, given equations. Okay. Then square root functions, how they are being found out. You see how graph is being constructed. And exponential function, where power is given, that is e to the power x, exponential function, how it is constructed, you see. Then logarithmic function, it is constructed in this way. Then functions related to business and economics, how they are related with this. Okay. So in case of demand function, how it is related, you have to, if suppose in question comes, you have to explain with the equation. Don't forget these equations. Okay. So the demand is a function of price. Okay. If price changes, demand also changes. That means it will directly affect the another variable. Okay. So if demand is if price is changed, demand is also changed. So demand function. Okay. Then same supply function. Supply, here you see, supply is also a function of price. If price changes, ultimately supply will also change. Okay. Then cost function, how it is related, you see. Total cost is the sum of fixed cost and variable cost. That is, the total cost is the fixed cost plus variable cost. Both are total, and then total cost is found out. Then fixed cost is the sum of all costs, that is independent of all level of output. Okay. That means example, rent, salaries of permanent workers. That means if salaries of workers will change, rent will also change. Okay. Variable cost is dependent on output. It increases with an increase in output. That is like suppose raw materials, salaries of temporary workers, etc. Okay. So here example is, that is equation is given. Suppose C is the total cost, and total cost is defined in this function, that is C equals to C of function X. Okay, X is total unit of output. Then profit function. Profit function is derived by considering profit earned and price of inputs and outputs. Okay, so if Rx and Cx, that is R of X and C of X, the total revenue and total cost function, then profit P of X is equals to R of X minus C of X, that is cost, total cost. Okay, total revenue minus total cost, that will be profit. Okay. Then consumption function. So it is proposed that consumption is the function of national income. Okay. So if national income is changed, so consumption will also vary. So if C denotes total assumption, consumption in the economy, so income denotes, that is Y denotes the national income. So function in this example you see C equals to f of y. Consumption is equals to, that is function of y. Okay, some equations are given. Okay, so just go through that. Here all the profit function, revenue function, they are not in numerical form, they are just a theoretical form. You just go through it. Okay, so that's all for today. Just let me teach you all the parts, and afterwards at the last class, fourth class, you just I will clarify your doubts. Okay, at the end of the class I will clarify it. Today just 3 classes I will discuss all the parts of the syllabus, or whatever parts of teaching is there, I will discuss that one and just go through it, and at last I will just sum up, or I will just discuss the question answers. Okay, okay, thank you.
Thank you, ma'am.